Hello, and welcome to Vvork. I'm Brian Watrous. This is the first in a 10-part video series in which we're exploring how to build a vCenter Orchestrator environment on top of VMware Fusion. As you can see, we have a number of different topics in this video series to cover, so let's jump right into the introduction. The purpose of this video series is to provide a blow-by-blow description of how to build a VCO lab environment. Now there's a variety of reasons why you might want to do that, one of which is many of you out there have talked with me about how you're trying to build an environment where you can learn to use VCO. The environment I'm laying out here would be a great environment to do that. Other reasons to create a VCO lab environment such as this is I need one that's ready to go wherever I happen to be traveling to. Because oftentimes I'm asked by people, when they find out that I know vCenter Orchestrator, people ask me to show it to them. So I need an environment to do demos. Or other times when somebody's really interested, I want to show them how to actually use it and provide a little bit of training. Again, having this environment with me all the time allows me to do that. But if those reasons don't fit for you, you could just create this mobile VCO lab environment simply because it's pretty cool. I'll show you in a few moments exactly just how cool it is. In doing this project, I laid out several goals for myself. One of which is that I wanted the lab environment to be entirely self-contained. I again need something that I can take with me on the road and have it all on my laptop and ready to go. So that was one of the primary goals. Another thing that was a goal was I wanted to have a VCO lab environment that was actually functional. I didn't want to have just a VCO server that didn't have anything to talk to. So as you'll soon see, I've got several hosts and a vCenter server in the lab environment to make things more interesting. I had a goal of achieving reasonable performance with this environment. Now, the word reasonable is subjective, but I think by the end of this video series, you'll see that the environment actually does run pretty well. It's pretty peppy. Additionally, I want to have a reasonable footprint in terms of the RAM that's required on the laptop and the amount of disk space. So you'll see I've employed various techniques to help cut down on the amount of those resources. And finally, I also wanted to make certain that this lab environment was going to be easy to start and stop. I didn't want to have to power on and power off each virtual machine individually. So those were the goals. On the other hand, there were some possible goals that I chose to not include in this project. For instance, one of them was I did not have VMware Workstation in mind in this particular project because I have a MacBook Pro and I'm running Fusion, so naturally it made more sense for me to go the Fusion route. For the viewers out there, if you are using a Linux machine or a Windows machine and you happen to have VMware Workstation, please feel free to use the techniques that I outline in this video series. You'll have to make some adjustments along the way, and I'd love to hear what you come up with. But the environment that I'm building here happens to be built on Fusion, but it should work equally well on top of Windows. Another issue that I chose not to tackle in this particular goal was the issue of security. There are a number of different ways in which the lab environment I'm building doesn't follow security hardening best practices. I'll strive to point those out as the video series unfolds. And another thing was the issue of official support. There are a number of things in the VCO lab environment that I'm building here that do not comply with VMware official support policies. Again, I'll point those out as we go along. Let's take a few moments to take a high-level overview of the architecture that we're building. As you can see, the hardware foundation is an Apple MacBook Pro. I'll give you more details about that MacBook in a few moments. On top of the MacBook Pro, I'm running VMware Fusion. Again, you could run VMware Workstation at this level, but in this video series we'll be using VMware Fusion. Now I run VMware Fusion in order to be able to create and run virtual machines, such as this Windows 7 VM. Now in this lab that I'm building in this video series, I happen to be using Windows 7. You don't have to use Windows 7. I use Windows 7 because I already had a virtual machine that had Windows 7 in it. Other versions of Windows should work equally well. Additionally, one of my goals in this project that I didn't mention before is to be able to power off that Windows 7 VM entirely once the rest of the infrastructure is installed and configured. I have that as a goal because just in case there is a shortage of memory in the infrastructure, powering off that machine will free up a good chunk of memory. Another virtual machine that we'll have running in our vCenter lab environment is a virtualized ESXi host. Now, this is the first instance of something in this architecture, in this lab environment, that's not an officially supported configuration. To be officially supported, you must run ESXi on a physical server platform. Here we're not. We're not running it directly on the hardware. We're running it as a virtual machine on top of Fusion. Now, for our purposes here, again, it wasn't my goal to create an officially supported environment, so we're going to be using virtualized ESXi hosts. This is the first one, and on that first one, we're going to be running the vCenter server virtual appliance. Over on a second ESXi host, we will be running the vCenter Orchestrator virtual appliance. Again, both of those VMs are running on virtualized hosts, not an officially supported configuration, but it'll work great for our lab environment. So let's go back to the physical hardware. The MacBook Pro, as you can see, is it's a 15-inch display. None of that really matters, but what does matter is that the physical CPU in the machine is a 2.7 gigahertz Intel Core i7, which is a quad-core hyper-threaded physical CPU, which means, from my perspective as a virtualization guy, that means I've got 8 logical CPUs that I can work with. Now, I'd actually like to take a few moments here to let you take a peek at those. I happen to be running a piece of software called iStat Menus. That piece of software is not actually required for this project, but I'm running it so that I can monitor what's going on in the infrastructure as I build it out. So these icons in the tray up top, including CPU, give me information from iStat Menus. As you can see here, I have 8 logical CPUs, and currently, in pretty much all the time I'm running on my MacBook Pro, the OS X operating system tends to favor running the various CPU workloads in only half of the hyperthreads. The other hyperthreads sit by essentially idly until something really interesting is going on. So as you can see here, I've got loads and loads of CPU cycles available. CPU is not ever likely to be a bottleneck in this particular lab environment. On the other hand, if we go take a look at memory, as you can see if you do some addition here, the physical host only has 16 gigabytes of memory. Now if you look at the graph up above, or this larger one over here, the two colored bands that are most important to us in terms of monitoring the physical memory usage in this environment are this blue band and the red band, which represent the wired memory and active memory. If you go looking online, you can find out at apple.com exactly what the difference is between wired versus active. For our purposes, the wired memory plus the active memory is the amount of memory that's actually in use. All this black stuff up top here in the black band is unused memory, and the gray band is inactive memory. That's memory that's been used recently by various processes running on the MacBook Pro, but those processes that are represented by the gray band are no longer running. OS X is just simply keeping around their memory pages so that if I were to start those programs again, I'd be able to very quickly restart them. Alright, so let's go back to our presentation, and as you can see here, as I pointed out before, the MacBook Pro that I'm using has 16 gigabytes of memory. It has a graphics card, not particularly important for our purposes. It has a serial number, but I've obfuscated that. That's my serial number. Yours will obviously be different. And you can see that I'm also running OS X, specifically 10.8.3, which is an older version of of OS 10. No, I'm not running Mavericks. Long story why. If you use Mavericks or various versions of OS 10, they should all work equally well. One other thing to be aware of in my lab environment is that my hard disks are not traditional spindle-based disks, but rather I'm using solid-state drives. I've got 0.5 terabyte of SSD in this MacBook Pro, which gives me a fair amount of space, but more importantly, it means that things run fast, fast, fast. In particular, shortly here we'll be talking about an issue known as VM kernel swapping, and the fact that I've got an SSD is going to alleviate the potential pain of that VM kernel swapping. The hypervisor that I'm running, as we saw before, is VMware Fusion. Specifically, I'm running the professional version 6.0.3. Now, as I've gone through this project, I've been using the professional version of Fusion simply because that's what I already had on my MacBook Pro. From what I could determine going through this project, I didn't ever see any professional features that I was using in this lab project. So if you're building a VCO lab environment on top of VMware Fusion, the non-professional version, that should work too. Again, for my viewers out there, if anyone happens to try that and finds otherwise, please let me know so I can let your fellow viewers know what the issues may be. Again, I don't think there are any issues, but let me know if there are. The Windows VM that I pointed out before, as you can see, is running Windows 7 Enterprise, Service Pack 1. That's the 32-bit version. Could run the 64-bit. I just, again, happen to have a Windows 7 32-bit VM lying around, so that's the one I'm using. You can see other things here, such as the amount of the amount of virtual memory that I've given the Windows 7 VM is 2 gigabytes, and the Windows VM is able to see straight through to the physical CPU. It sees that I'm running the Windows VM atop that Intel Core i7. You can see the speed of the CPU, but from our perspective, the virtual machine does not see all 8 logical CPUs. Because I've only given the virtual machine 2 virtual CPUs, it will only at most run on 2 logical CPUs at a time. 2 virtual CPUs is probably overkill here. I just find Windows runs better when you don't single thread it. As I said before, the ESXi hosts that we're going to be running in this lab environment are virtualized ESXi hosts. Specifically, they're running VMware ESXi 5.5 Update 1. And you can see in the slide here the ISO that we'll be downloading in the next video that will serve as the installation media for installing our ESXi hosts. Now, I will initially configure both hosts to have 2 virtual CPUs and 4 gigabytes of RAM. Additionally, each host will be equipped with a 40 gigabyte thin provision virtual disk. If you are familiar with thin provision virtual disks, you already know why I chose thin provision. If you're not familiar with thin provision, the simple version of thin provision is that by making that choice, by making that type of virtual disk, I will significantly reduce the amount of disk space that's required by these virtualized ESXi hosts. So even though the drives appear to be 40 gigabytes, the actual amount of space allocated will be considerably smaller. Each host will be, at least initially, equipped with a single virtual NIC. I will configure that in VMware Fusion in Share with my Mac mode. Later on, we might choose to add an additional virtual NIC into each host so that we can do exciting things such as vMotion migrations. Initially, though, we'll just go with one virtual NIC. And each virtualized host is going to have a virtual CD-ROM that we will point to the ISO that we mentioned on the previous page. The vCenter VM that we will be installing is based on the VMware vCenter Virtual Appliance, specifically 5.5 Update 1A. Unlike the installation media for the hypervisor, which was an ISO, in the case of the vCenter Server Virtual Appliance, that's a .ova file. You can see the name of the OVA file that we'll be using listed on the screen. Now, the vCenter Server Virtual Appliance that we're going to deploy by default is going to be configured with 2 virtual CPUs and 8 gigabytes of virtual memory. Now, if you're paying attention, that's an 8 gigabyte VM on top of a 4 gigabyte host. So 8 gigabytes of virtual memory on a 4 gigabyte physical memory host. Now, if you're thinking to yourself, that sounds like a recipe for abysmal performance, let me show you a chart that I consulted while I was building out the lab environment the first time. As you can see here in this chart, we're looking at the memory consumption of the vCenter server virtual appliance. Now, if you look first at the active memory line, that's the yellow line, you can see that when the vCenter server initially powers on, its active memory portion jumps up to almost 7 gigabytes, but pretty quickly thereafter, the amount of active memory tapers off to a pretty low level. In fact, if you look way over on the right, it looks like we're under 1 gigabyte of active memory use. So we actually have a lot of wiggle room in terms of memory. So even though this is an 8 gigabyte virtual machine on a 4 gigabyte host, we're actually doing very well without having made any adjustments so far at all. Now, one of the things you will notice, though, is that as a result of that high memory consumption, the VM kernel, as you can see, a little after 4:35 in the morning, the VM kernel engaged the balloon driver to reclaim some of the memory from that vCenter server virtual appliance. Now, it only did that initially, and it hasn't gobbled up more, so that's actually okay. The VM kernel has that memory available to give to other virtual machines, but since there are currently no other virtual machines on this host, if the vCenter server virtual appliance needs that memory back, it's going to be able to get it back rather easily. Now, one other line shows up on this graph, although it's kind of hard to see. Down on the bottom, the gray line is representing the amount of VM kernel swapping that's taking place. Now, ideally, we want 0 VM kernel swapping. As you can see, we have a little bit, but that little bit is pretty tiny, and is especially tiny when you consider that that VM kernel swapping that's taking place is actually hitting an SSD drive. But that's not good enough for me. I want to completely eliminate that VM kernel swapping if at all possible. In fact, I want to eliminate that balloon driver activity if I can. Now, later on in the video series, I'll show you some tricks that are going to enable me to do that. I won't tell you what those are right now. Instead, I'm going to keep it as a big mystery so that you watch all the videos. Alright, so let's move on here. Again, back to the vCenter server. The vCenter server virtual appliance is going to have 2 virtual CPUs, 8 gigabytes of memory, 2 virtual disks, which collectively appear to consume quite a significant amount of disk space, but once again, these are thin provisions, so it shouldn't be a big deal. The vCenter server virtual appliance will be configured by default with a single vNIC configured as a VMXNet3, and that virtual appliance will also have a virtual CD-ROM, but it's going to be disconnected by default. The VCO server that we're going to be running is based on the VMware vCenter Orchestrator Appliance version 5.5, update 1. Again, its installation media is a .ova file. You can see the name of it. That's the file that we're going to be downloading and installing. The VCO server, when we deploy it, by default is going to have 2 virtual CPUs, 3 gigabytes of virtual memory, which is below the 4 gigabytes of physical memory that the host itself has. The VCO server virtual appliance will have 2 virtual disks. They're not that large and they're thin provision, so we should be pretty good there. Not a lot of concern about disk space. In terms of networking, the VCO server virtual appliance is going to be equipped with a VMXNet3 virtual NIC, and once again a virtual CD-ROM drive, but that CD-ROM drive will be disconnected. Now, just for sake of completeness, here's that same graph. The graph you saw before is for the vCenter server. This is the graph for the VCO server. As you can see, at its peak, the active memory usage was, what is that? That's about 2 gigabytes. And once again, it tapered right off, just like it did in the vCenter vCenter server virtual appliance. In the case of the VCO server, no ballooning, no swapping, so things are looking really, really good on the second host. Okay, so that's the VCO server. Up towards the top of this slide, I mentioned that we're going to be using VMware licenses, and actually, strictly speaking, that's not true. We're going to install each of these products, Fusion, ESXi, vCenter, and VCO. In each case, when we install those, we're not going to install a license, which means that each of those products will go into VMware's 60-day evaluation mode with all the features and bells and whistles turned on. Now, that gives you 60 days to work with this lab environment. After 60 days, things are going to start getting locked down. So before the 60 days expires, you'll want to take a look at getting yourself some licenses. Anyways, there's one more slide here, and this one's actually an important one. You won't see this immediately, but when it comes time to start configuring the hosts, you need to have disabled the keyboard shortcuts that you see listed here on the screen. I myself, when I first started doing this, found myself continuously going back to system preferences in order to unmap each of these keyboard shortcuts. Just get it out of the way. Unmap those keyboard shortcuts right from the start. Otherwise, once you start configuring the hosts, in particular when you start going into the direct console user interface, you're going to find that the DCUI uses these keyboard shortcuts. So turn them off before you get too far into the video series here. Again, Apple's system preferences is where you go to do that. Now, this was just an introduction. There's 9 other videos. Make certain that you stick around because we've got lots and lots of details coming up showing you how to build that entire VCO lab environment. In the next video, we're going to take a look at exactly what pieces of software that you need to download, where you need to download them so that you can build your VCO lab environment.